Hey, hi everyone. Welcome back to the channel. In this particular video, we are going to talk about Kubernetes service object. So it is very important object in the Kubernetes because by using that object, we can access the application deployed in the Kubernetes cluster as a pod, right? So we'll see what is service, what are different types of service, and then we'll see an example where we'll use the different types of services and we'll see how we can access that application in the which is running in the cluster. Okay, so let me just share my screen to quickly show you how it works. So this is my whiteboard. This is where I'm going to quickly explain on how the service object will look like. So let me use some different colors. Let me use a red color here. Okay, so let's say this is our cluster. Okay, this is our cluster. And for example, we have a 3-node cluster. Okay, we have 3-node cluster. So let me just draw it. Now, let's consider that we already seen the deployment object in the Kubernetes. So that deployment object in the Kubernetes basically help us to deploy our application and create the multiple replicas of our any specific microservice. So let's consider that we created, okay, let's say we have one front-end microservice and that we deployed as a deployment. And there, okay, we have, let's say, 2 replicas. So one replica got created on the node 2. I'm just naming these nodes. So one replica got created on the node 2 and one replica got created on the node 3. Okay, and this is, let's say, a UI replica, sorry, UI deployment. Okay, so 2 replicas, those are running. And then let's say we have another microservice, let's say database. So for that, one replica is running on the node 1 and another one is running on the node 2. Okay, now if let's say an external user wants to access the UI deployment, now we cannot directly give an access to our UI pod to this end user because the pods that we create does not have a specific identity, right? Because the names that we assign it to the pod as well as the IP assigned it to the pod, that gets keep changing as soon as the pod get restarted. Okay. Also, we cannot give any specific node IP to go and ask to get the pod access from that node, because even right now, if this UI pod is running here, and if you created it with the help of deployment, if due to some reason this pod goes down, it might get created on some other node next time, right? So even we can't give the directly a node details as well. In that case, how we can access the application which is running in the Kubernetes cluster? So that is where Kubernetes provides a service object. Okay, where basically there are 2 types of services. One is ClusterIP service, ClusterIP service, and the second one is a NodePort service. So now what is the use of this? So we should use a NodePort service. Okay, we should use a NodePort service if you want your application to be accessed outside of the cluster. So now our application's front end is something that we need to access it outside of the cluster, right? So for that, we need to create a NodePort service. So when we create a NodePort service, that is a virtual object and which will seat something like this, okay, which is a kind of a has a complete cluster visibility. Okay, so we'll be creating a NodePort service. So we should create a NodePort service if you want to access our application to be outside of the cluster. So now this UI pod, we are going to access it outside of the cluster, right? That's the reason for this UI pod, we are creating a NodePort service. Similarly, now for this database pod, okay, database pod, we need to create it inside the cluster only. Okay, so in that case, if you want your application to be accessed from inside the cluster, so in that case, we should use a ClusterIP service. So now this UI pod wants to talk to the database pod. So this is an inter-cluster communication, intra-cluster communication. So for that, we should create a ClusterIP service. So that will also be similar to like this. Okay, it will be having a complete visibility. So we'll be creating a cluster IP service for inter-pod communication, right? And then in each of this service, what we do is basically, so similar in a Docker, what we do is basically, this is our Docker host, and inside this Docker host, we create a container. And to make this accessible container, let's say which is running on 8080, to make it accessible, we bind it to the host machine, let's say 8000 port. Okay, and then the end user can just simply access it like this. Okay, the IP of the host machine colon 8000, and then due to this binding, the traffic will be forwarded to inside this container. So similarly here as well, what happens whenever we create a NodePort service, automatically this service NodePort service will automatically get binded to all the nodes. Okay, it will get binded all the nodes, and one of the NodePort will be assigned, like for example an 8000. Okay, so 8000 port will be automatically assigned to all the nodes. Now as this assignment happens, due to this, the end user can use the IP of any node. Okay, we have 3 nodes, so he can use node 1, node 2, node 3. And if we use a colon 8000, okay, the traffic will land to that specific node. But yeah, we can use any node because by default Kubernetes will bind it on all the nodes of the cluster. So we can use any node IP colon the node port. Okay, so as soon as this user wants to access the UI, so it will send the traffic to the one of the node IP colon 8000. So traffic will land it on the node port. From there, it will go to the service, the node port service. So for every service, there will be a one virtual port as well. Let's say that is a 80. So you can have you can give any port here, a virtual port for this particular node port service. And then from there, how this node port will service will understand that where these UI ports are running, because they can keep changing their location, right? If they're running now on a node 2 and node 3. If due to some reason those pod goes down, they might get scheduled on some other node as well. So what this service does, basically, it has one selector attribute. Okay, whenever we write our service YAML, you will get an idea. So in the selector, we specify that, okay, let's say app is equal to UI. This kind of a filtering or the labeling, we can use it. So as soon as the traffic reaches to the NodePort service, we'll have a selection criteria where it will say that, okay, give me all the pods having label app is equal to UI. So wherever they are running, on whichever node they are running, it will get an idea, okay, where these are running. And then accordingly, this service will send the traffic to the port of that UI pod. Okay, let's say it's running on 8080. So it will, okay, and we call this as a target port. So that service will send some traffic to this UI pod, some traffic to this pod, and this service is by default capable of doing the load balancing. Okay, so it will send the some traffic to this UI pod which is running on node 2, some traffic to the UI pod which is running on node 3. So this is how the traffic will reach to the UI pod. Now UI pod wants to talk to the database. So for that, we created a cluster IP service. So same thing, UI pod will send the traffic to the cluster IP service. Again, for cluster IP service might be running on some virtual port, let's say 81. Okay, so and from there, it will send the traffic, some traffic to this database pod, some traffic to this database pod. So similarly for cluster IP service as well, you are going to use the selector, and in that selector, we are going to specify that app is equal to database. Okay, so this way, it will kind of hit a query that, okay, give me all the pods having label app is equal to DB. So this 2 pod will found and it will send the traffic to this. Okay, so this is how basically the flow is. Okay, let me just quickly repeat. The user can use any node IP. So any node IP colon 8000. So traffic will land it on one of the node. From there, it will go to the node port service. From that node port, it will go to the pod where it is running. From that pod, you can again send it to the cluster IP service. And from there, it will go to the database pod. And how each service is going to send the traffic to a specific pod, that is on the basis of the label. So every pod will have the labels. And by using that label, it will find where those pods are running and the traffic will be sent. So this is how it will look like. So now to get a better understanding, I'm going to basically take one example. And by using that example, we'll understand practically how it works, right? So the example that I'm going to see that, the one that I'm going to show you, it has 2 pods. Okay. And this we call it as a web pod, and this we'll call it as a database pod. Okay, so for this database pod, I'm going to basically use a MySQL image. Okay, so by using a MySQL image, I'm going to simply create a one database pod. And in the web pod, I'll have 2 containers. Okay, one is a Python container and then another one is a Redis cache container. So for Redis, I'm going to use a ready-made Redis image, so which will be using as a cache database. And for Python, I have an application. Okay, so this application has basically three API. One is init API, second add user API, and the third one is a get user API. So where we'll provide a user and some ID of the user ID. Okay. So now I'll talk about this API. Before that, now this pod will be accessed outside of the cluster. So we'll be creating one NodePort service for this. And this, okay, to communicate web pod to the database pod, we are going to create a ClusterIP service. Okay, we are going to create a ClusterIP service. Okay, so this web pod will talk to the database pod via this ClusterIP service, and then this end user is going to talk to the web pod by using this NodePort service. Okay, this is how the communication would be there. Now, what these three APIs are doing, this is an init API. This Python application will simply connect to the database pod and then create the table, user table. Okay, it is going to create one user table here. Okay, and then add user, what it will do, while adding a user, it will pass a user ID and username. It will again simply connect to the MySQL, and then it will add the user ID 1A, user ID 2B. Like this, it will add the data. Okay, and then the get user or a user and then ID. This API, what it will do, it will first of all talk to the Redis container. The container from the same pod, they can directly talk to each other by using localhost :port. So if this is running on 6379, so Python wants to talk to the Redis, so you will do localhost :6379, right? So as soon as if you want to get the user details, so let's say we pass a user ID 1. So it will first of all check if it is there in the Redis. So obviously for the first time, it won't be there, right? So it will go fetch it from the database, MySQL database. It will store that data here. Okay. And then once stored, it will send it back to the end user. Okay. And this is a cache database. So it will store this data for a specific period of time, let's say 60 seconds. So within a 60 seconds, if we get another request to access the user ID 1 detail only, then this Redis cache itself, it is going to return. If we get the request after 60 seconds or for some other user ID, we'll again connecting back to the database, fetching it, store the data here in the cache and returning it, right? So this is what the application is. So let me just quickly show you this practically, okay? Whatever the explanation I have given, basically all this available on my Git repo. So this is my Git repo where we have a service demo. So all the discussion that I have done on the application, how it works, okay, how to use this all command and all stuff, it is available in this Git repo, right? So what I'm going to do is I have a one Kubernetes cluster. I'll just copy this Git repo and then I can just simply go ahead and show you practically. So what I'm going to do, my Kubernetes cluster is already ready. So what I'll do, I'll just set an alias k is equal to qc here so that we can use this. And then you can see my cluster is up and running, right? So let me just clone this code. And then I'll step by step also explain you the code. So this is my service demo repo. Inside this, we have two folders. The build folder has all the code and how to build it and all. And the deploy folder has the actual YAML files. So let me go to the build folder. In this folder, you can see, first of all, we have a app.py. So this is our Python application. So here you can see Python application is using a lot of different Python modules. Then more importantly, it is connecting to the Redis container by using just a localhost :6379. We are going to pass this as an environment variable as a localhost. Then to connect to the MySQL, we are just simply providing this is our MySQL pod name and root and password we are passing. Okay. So you can see here in the init API. So we don't have to worry about how to write this code because this is something the developers will write it and will get the code. Okay. So just to a better understanding, I am basically explaining this code. So in the init API, you can see we are simply connecting to the database and creating the table. That's it. And we'll get the message database initialization is done. Then in the user add, we are simply connecting to the database and inserting this data into the database. That's it. Right. And then in the get user, what we are doing is we are first of all checking if it is there in the cache. So obviously first time it won't be there. So we'll go into the else, we'll fetch it from the database, we'll store it into the cache and we'll return it. Okay. For next time, if you get the same user ID, it will simply return it with a C appended. And this application is running on 5000. So this is how the simple application is. Now, basically to build this Docker image and push it to the Docker hub, that is something we have already seen in our Docker playlist. You can go and visit that particular part. So I'm not going to build it and push it because I have already done it. So it is already available on my Docker hub. So we'll directly use this image. Okay. So, but yeah, if you want, you will find all the details in this folder. I'll share this link in the description so you can use it. So let me go to the deploy folder. Now here in the deploy folder, you will see the database pod.yaml. Okay, so this is our database pod. You can see here, nothing fancy. Most importantly, these are the labels I am adding on the pod. Then I am using this MySQL image, which runs on 3306, and it is expecting MySQL root password as an environment variable. So this is the simplest possible DB pod YAML we have. So let me just quickly create it. So kubectl apply -f dbpod.yaml. So it got created. Now let me show you the db svc.yaml. So if I open it, so first of all, you can see these are all the basic attributes. But more importantly, you can see this is a virtual port. You can give anything. The target port is nothing but where our pod is running on which port. So it is also running on 3306. And then how this service is going to understand like where I need to send the traffic on the basis of this label. So exactly this label we have added in the DB pod. So by using this label, this service will understand that, okay, I need to send a traffic to the pod having this particular label, right? So let me just create this. So kubectl apply -f db_svc.yaml. So it got created. Now if I do kubectl get all, you can see your MySQL pod is running, and as well as here your MySQL service is running. So this is a ClusterIP service, right? So in our db_svc.yaml, we have not specified the type of the service, right? So when you don't specify, by default, the type of the service is ClusterIP. So let me just show you the web pod now. Web pod. So here in the web pod, we have two containers, right? So this is a Redis container. We are using a ready-made image which runs on 6379, right? And then this is the application which I have already built and pushed it on the Docker of the one that I was explaining, where I'm passing an environment variable as a Redis host, as a local host, and then it is running on 5000. So it has two containers in this particular pod. So let me just save it and then create it. kubectl apply -f webpod.yaml. So if I run it, so you can see it got created. So here it is, say you can see it is 0 out of 2. That means here are two containers that are supposed to be created. So they are still running. By the time, let me just show you the web svc.yaml. So here you can see, first of all, the selector, okay, the label that we have added it on the web pod. Okay, this is the exact label we are using. Then type of the service is a NodePort, okay, because we want to access this outside. Our web pod, we want to access it outside of the cluster. So this port is a virtual port on the service. This target port is nothing but where our application is running, okay. So let me save it and create this as well. So kubectl apply -f web svc.yaml. So that is also got created. So now if I do kubectl get all, so you can see everything is running. The web pod is running, the MySQL pod is running, MySQL service, ClusterIP service running, web NodePort service running. Now how to access it? So basically it is binding, okay. When you don't provide on which port or on the host it should bind, randomly it will take port between 30,000 to 32,000. So it took this port 30,171. So that is something you can use it. So what we can do is now we can use any node IP colon this port, and we should be able to access the application. So let me see. First of all, let's get the node IP. So kubectl get node -OID. If you do, here we got the node IP. So you can use any node IP. So I'll use curl this IP colon, what is the port? 30171. So this is the port I'm talking about. So we got this port, and then we have to use API, right? So what is the first API we have? Init. So as soon as I do it, you can see here database initialization is done, right? What is the next API is to add the user. So to add the user, basically we need to pass some JSON data, and this is how you can pass it. Okay, here you can find a sample curl payload, how you can pass it. This is what I'm trying to pass it. So let me just copy this. So let's say this is the user details I'm going to enter. So let's go back, and here what I'm doing is perfect. So now I'm passing this user details and init. Okay, instead of init, the API name, second user API name is add users. Okay, so if I run, or is the users add, I don't remember. Let's tag users /add. So if I run it, yeah, so you can see user got added. So let me add another user. So I'll keep this as is. Then I'll use the user ID 2. Okay, we'll use the user ID 2, and then here I'll use the let's say user is Bob. Okay, I'm using another username is Bob. Perfect. So this second user is also added, right? Now what we are going to do is use the third API, users/ID to fetch it. So for this is, I'm trying to do it for the first time. So if I do it, you can see we got a John Doe, right? So obviously for the first time, it won't be in the cache, so it will fetch it from the database. But if I try it again, it should basically get it from the uh, cache itself, right? So let me just try to get it. Looks like this got disconnected. Just give me a second. Let me just try to duplicate the terminal. Oh, sorry, it got disconnected, look like. Let me just have a look at it once. Okay, sorry guys, there was a little bit drop. So I'm back. So let me just continue where we left off. So here what we're doing is basically we're trying to just access it, right? So let me just see kubectl get all. So everything should be running perfectly fine, right? So we are trying to access it, the user, right? So if I do curl, let me do get the node IP first of all, once again. Okay, so this is the node IP. I can just use the curl, this node IP colon, what is the port? 30171 slash users slash 1. So if I give it, now we are doing it for the first time, so we'll get a John Doe as it is because it is fetching it from the MySQL directly. But if I check it again, this time you can see I got a C appended. That means it's getting it from the cache, right? So let me do it once again. I'll try it for user 2 because here you can see we got the Bob as a response, right? So because we are trying it for the first time, so it is fetching it from the database. So let me do it once again. This time you can see C appended. That means it is coming from the cache database, right? So yeah, yes, this is how we basically make our application accessible, right? That's what we have done it here, right? So to access our web pod, we use the NodePort service, and to access our database pod, we have used the ClusterIP service. So I hope everyone understood how the service object of the Kubernetes works. If you have any queries, please put it in the comments. If you like this video, please share it with your friends. And if you're not subscribed the channel, please do subscribe. So that's it for this video. Thanks everyone. See you again.